So now that we have discussed about finite and infinite sets which are related to countable and uncountable, so mathematics realizes the importance of identifying the number of elements in a set, and hence there's a new concept introduced called the cardinal number. Identifying the number of elements of a set is very important in justifying the set for a finite or an infinite set. Therefore, let's see what a cardinal number is. Now, cardinal number is nothing but it is the number of elements inside the set. So cardinal number is nothing but the number of elements inside the set when you count them. Say for example, but before this, it is denoted by set A. It is denoted with n of A for any set A. The notation for cardinal number is n of A. So, for example, I take A is equal to A, E, I, O, U. Then my cardinal number for this set denoted by n of A is the number of elements inside the set. 1, 2, 3, 4, 5. So the answer for this is 5. The cardinal number of set A consisting of all vowels is 5. Similarly, is the question. The singleton set is a set which has only one single element inside the set. Therefore, cardinal number of a singleton set is always 1. This is always for any singleton set, the cardinal number is 1 always. Next, what will be the cardinal number of null set? As we already discussed, we need to revisit the definition of a null set to identify the cardinal number of a null or an empty set. We know that an empty set doesn't consist of any elements. The number of elements mathematically in a null set is 0. Therefore, cardinal number of null set is the number of elements which is 0, and hence of the null set is 0. Cardinal number of 5 is 0. Say I take the cardinal number of integers. The numbers which we identify in integers range from -infinity to infinity. Therefore, there are infinitely many numbers which exist in integers. Therefore, cardinal number of z is tending to infinity. We cannot exactly identify the exact value. Therefore, the cardinal number of integers tends to infinity. Now, I want to take an interesting example for finding the cardinal number, because this example makes us understand on how important is realizing the set before realizing its cardinal number. So for example, I have set of all odd numbers which give the remainder as 0 when divided by 2. The whole question has many mathematical properties hidden inside the statements. So it is very important to identify and understand this statement before we generate the roster form of this statement and then find the cardinal number. Now, set of all odd numbers. We all know what are odd numbers, but the post condition out here is that the set of all odd numbers which give the remainder as 0, we need to pick only those odd numbers which make the remainder 0 when divided with the fixed value 2. So how many numbers exist which give the remainder 0 when divided by 2 is the first identification we need to make in case of this example problem. So when I take the set of all odd numbers, so let me pick up all the odd numbers 1, 3, 5, 7, 9 and so on and so forth. Now I want to divide each of the odd number with 2 such that I get the remainder as 0. Is there any possibility that when I divide an odd number with 2 I get the remainder 0? So let's test if it is possible. So let me randomly pick one of the odd number, say 5, and I divide 5 with 2 and see what is the remainder. 1 is the remainder, but I want that number which gives the remainder as 0. So this does not work out. So 5 fails in coming into the set as desired out here. Similarly, I pick up 9 and then I say I divide with 2, then let me see what is the remainder. 2 4s 8 and 1, and then again the remainder is 1 but not 0. So I make a conjecture that any odd number is not divisible by 2, therefore definitely the remainder will not be 0. So this contradicts the statement that we cannot pick any number which gives the remainder 0 when divided by 2, the number being an odd number. So therefore the whole of the set does not consist of any element or any number which satisfies the condition that it must be an odd number with remainder 0 when divided by 2. That means there is no element. No element is identified as no element or this. So the whole of the set is identified as the null set because no element inside. The null set instead is again identified as the cardinal number of S is 0. Therefore, when I wanted to find the number of elements in the set of odd numbers which give the remainder 0 when divided by 2, indirectly